How do geologists come up with million-year ages? Are radioactive dating methods accurate? Our guest today, a creation paleontologist, discusses these issues in a clear and understandable way. Along the way, you'll discover that creationists have done some great research and have some amazing answers to this challenging issue. Coming up on today's edition of Origins, Rocks as Clocks with Dr. Marcus Ross. Hello, my friends, and welcome to Origins. My name is Donn Chapman. It's my privilege to be your host. During this program, we showcase interesting guests who present evidence from science, along with other important facts, validating the truth of creation and the accuracy of the Bible. Today's guest, Dr. Marcus Ross, received his PhD in environmental sciences from the University of Rhode Island, where he researched all sorts of fossils, including a group of extinct marine reptiles known as mosasaurs. Since 2005, he's taught geology, paleontology, and creation studies at Liberty University in Lynchburg, Virginia. He's greatly interested in the issues surrounding the creation-evolution debate. Welcome, Dr. Marcus Ross.
Thank you very much, Donn.
Dr. Ross, it's a privilege to have you.
It's wonderful to be on the show.
And our subject today is one that has great interest, I know, among our viewers. Rocks as clocks. We're going to address that today, aren't we?
Absolutely. I mean, today is going to be a lot of information as we're going to go through, but we're going to try and take the science aspect and bring it down so that it's in nice bite-sized chunks people can understand, and we're going to work through some tough science, but some very fun science and very, very relevant stuff for creation and evolution issues.
Well, we're thrilled to have you, and your input is going to be, I think, very valuable.
Well, to start off, what we need to do is understand what kind of dating of geology that we're talking about here. Now, when geologists think about geological dating issues, they think in terms of two types or two varieties. One of them is called relative dating. Now, relative dating is all about trying to put the rocks of the world in a sequence and in order based on their physical position and the fossils that are found in them. You know, which rock formed first and second and third. But an important component for relative dating is not that you're putting numbers on. It's just that you're trying to figure out an order, a sequence. What we're interested in today is what's called radioactive dating or radiometric dating. That is the one that's the real challenge for the young Earth creation community, because it's from this set of geological dating methods that we presumably get multi-million and multi-billion year ages. Now, this system is using the decay of radioactive elements. Basically, you've got some atoms out there that are not entirely stable, and over time they change into other things. We'll see kind of how. And what we use is the original material and its products, and we use that as kind of a timekeeping device. And so this is the argument. It happens
at a certain rate.
That's right.
Yeah.
That's right. So when you get asked questions about carbon-14, or somebody says, well, what about uranium or some of the other exotic atoms and elements involved? That's what we're going to be looking at. How do those things provide a numerical age? And what is it that a creationist response to those issues can be? So as a paleontologist and as a geologist, I usually think about what we call the geological column. And that's this setup of rocks, usually a colorful image like this from my textbook, that divides the rocks of the world into things like the Paleozoic and the Mesozoic, and inside that you've got the Jurassic and the Cretaceous. And on one side of that, usually, are old Earth ages, with the youngest rocks are up at the top, because when gravity works and stacks things, the youngest things are at the top. The oldest things are at the bottom, and you can see that the old Earth side of things has got these ages. 4.5 billion years or so for the origin of the Earth, the beginning of our fossiliferous layers of sedimentary rocks about 500 and some odd million years ago, and so on and so forth. So these numbers are the things that are the real challenge for a creationist to say, okay, how do we understand these data themselves? So what we're going to be investigating here are radioactive isotopes, which means that you've got a material, and geologists call that a parent material, that eventually decays into some other material that we call the daughter. And why geologists don't like their sons, I don't know, but we always have parents and daughters when we talk about these things. So for example, carbon-14. You get asked about carbon-14, they're asking about the parent. And so carbon-14 is a radioactive material, and over time it will decay into something else. It'll decay into something like nitrogen. So that's going to be the daughter product of carbon-14. And so the parent will decrease over time and decrease very quickly and then kind of flatten out, as we'll see. And for every one atom of carbon-14 that decays, it turns into one atom of nitrogen-14. And so as one decays, the other one's growing. So geologists then measure the amount of time that it takes for a certain number of the parent to decay into a certain number of the daughter, and they convert that into what's called a half-life. Half-life means basically what's the amount of time that it takes for a complete sample to turn into half of the original and now half of the radioactive daughter product over time. So let's think of it this way. I like pies. My wife makes fabulous pies. So let's say that for a moment she's made a blueberry pie. So let's say that we're looking at this pie, and this pie represents 100% of a radioactive material, 100% of the parent. And there's no daughter product yet. We've just baked the pie. It's fresh out of the oven here. Now, with a half-life, what happens next is that over a certain period of time, half of that pie is, well, in the case of a blueberry pie, consumed. I eat it. Now, let's say that the next night, I'm going to eat half of what remains, right? We started off with 50%, and now I've eaten another 50% out of what was there. And now we only have a quarter of the pie left. I've been eating pie for 2 nights. So now we've got 2 half-lives that have gone through 2 nights. There's 25% of the parent left, and there's 75% of the daughter product, in this case, no pie, right? Well, on the 3rd night, I eat another half of the pie. Again, every time that I'm at this, I'm only eating half of what happens to be there. And so as a result, we've got a half of a half of a half, which means we've got 3 half-lives that have gone through now. We have 12 or 13% of our original pie left, and 87% of the pie is gone. What a geologist is doing is that they're looking inside minerals or other materials, and they're looking to see how much of the pie is left. Because under certain circumstances, you might know that you started with a whole pie, and for the geologist, it's not an empty pie pan that they're looking at. It
turns into something else.
That's right.
Yeah.
So this might be the carbon-14. This might be the nitrogen-14 that is produced as a byproduct of the radioactive decay. So hopefully that gets us an idea of what's going on with half-life. Now, what you'd understand then is if you came to my house and you saw that there was one little piece of blueberry pie left, right, 1/8 of a pan, and you knew that every night I ate half of the pie, you could estimate then, based on the evidence that's been left behind, how many nights I've been eating pie, right? So a geologist is looking to do the same kind of thing. We're looking at these ratios. The geologist, however, usually plots it on a diagram that looks like this. Now, our pie is still in here, it just looks a little bit different. Our first pie is up over here with the 100%. Our second pie is over here at 50%, and then so on and so forth, smaller and smaller. What we have in here with a couple of the things is that, what if you caught me as I was just starting to eat, and it wasn't a full half-life, right? It would be harder to estimate on the pie issue what that is. And so a geologist, if they find, say, uranium, and they find that most of the uranium is still there, you've got almost 88% of your uranium, they trace that down through here and find out that that means that 1/4 of a half-life has gone through. The geologist then takes that value of 1/4 and multiplies it by how fast the radioactive atom tends to decay. And so that will give you your age. You multiply this 1/4 times however fast uranium decays, and that gives you the age for the sample. All right, so types of radioactive dating. There are a variety of different radioactive elements out there. Most of them are names on the periodic table that mercifully we never had to know in chemistry. You've got uranium, a couple of different types there, thorium, then you have potassium, then you get things like rubidium, which decays into strontium, all these odd names. But the take home from this diagram here, this chart and table, is that most of the half-lives are all measured in hundreds of millions or billions of years. These things decay very slowly. You're nibbling the pie a little piece at a time, not quickly. In comparison, you mentioned carbon dating. Now, carbon-14, on the other hand, as it decays into nitrogen, does so very, very quickly in comparison. 5,730 years is how long it takes to lose half your pie. and then after another 5,730 years, you lose half of the pie that was left, and so on and so forth. So carbon-14 is going to be used to date geologically recent things because the pie decays so quick. These items over here are the ones that are usually used to date when the dinosaurs died out, when a lava erupted in the deep past, things like that. So what we're going to do is we're going to focus on the carbon-14 system because this is the one that people hear about more frequently.
It is.
We hear about it in geology. We also hear about it in archaeology, right? They date a piece of papyrus. So why is that? Well, all carbon has 6 protons. Now, if you remember back to way back to early chemistry, the nucleus of an atom is made up of protons and neutrons. Protons have a positive charge and neutrons have no charge, and then there's electrons that circle around them. So in order to be carbon, your identity card, your ID, means 6 protons. Carbon-14 has a few more neutrons than most carbon does. It has 8. Most carbon has 6. And this creates an instability in the atom. And so every once in a while, the atom kind of has a kind of psychotic episode and converts and becomes something else. And that's the radioactivity component here. It tosses out something called a beta particle, which we don't have to worry about too much here, but it becomes nitrogen. One of these neutrons right over here, its neutral charge, it sends out a negative part, leaving a positive part behind, and so it actually switches positions. It goes from a neutron and becomes a proton, and so it changes from 6 protons to be carbon to 7 protons, and it's now nitrogen. It's a different atom altogether. So how does this happen, and why do we use it for dating? Well, carbon-14 is actually being made all the time. Did you have breakfast this morning?
Yes, sir.
You ate radioactive food. And it wasn't your wife's fault. It wasn't her cooking. It's because all of our food has trace amounts of carbon-14 in it because carbon-14 is made in the atmosphere. Solar radiation comes through, and through a couple of explosions that happen in the high atmosphere, it converts things like nitrogen into carbon-14 in the first place. That carbon-14 then binds with oxygen and forms carbon dioxide, and plants love carbon dioxide, right? They take that in, they absorb it, and they make plant stuff out of it. They make their leaves up in here, they make their roots, they make apples, they make wheat. So everything that's made of plant material is made with a small amount of carbon-14, just 1 out of a trillion, little tiny amounts, but it means that all of our food is radioactive. Now the good news is, as far as how long we live, this doesn't affect our body, and it's so small amount our body repairs any damage. But it means that since I ate breakfast today, and I either ate a plant or I ate something that ate the plant. I had some sausage this morning with my breakfast, and so that pig was being fed corn, which had carbon-14 in it, so the pig had carbon-14 in it. So the entire biosphere has got carbon-14 in it. So thinking about how carbon-14 works, we're pulling in this carbon-14, and it turns out that the rate that it's produced in the atmosphere is the same rate that it decays. And so there's a balance between what I took in this morning versus what my body has released as carbon-14 is decayed. It's almost like your body's a bathtub with water coming in and water coming out, and the level never,
Same rate they're coming in and out, yeah.
Exactly, and that's important for the dating component for how we then use it. So when an organism dies, it stops eating. Not that I discovered this rule of biology, but that means that if, again, we think about that bathtub analogy, once you die, you turn off the water that's coming in, but the water that's leaving, the carbon-14 that's leaving from decay, keeps going, and so the level of the bathtub keeps dropping. It's no longer staying the same because you're now dead. You're not taking in any more. So the carbon-14 keeps decaying into nitrogen at a certain rate, and so geologists or archaeologists, the people who are running the experiments, what they do is they compare the normal amount of carbon-12 in your body to the radioactive carbon that's in your body, and they have a fixed ratio and then say, okay, well, how much is it compared to that ratio? And the lower it is, the more time has gone on. Okay. So we can date carbon-14 items from anything that used to be alive. So we can't date a rock, because a rock wasn't eating plants, but we can date wood, we can date charcoal, shells, bone. All those materials were alive at one point, and now are dead, and so can be carbon-14 dated. Now, there's some limitations to this. You can't get a multi-million year age because the pie gets eaten too fast, right? It decays too quick. You do have to worry about contamination. Is there ways in which carbon-14 that's modern can be put into an old material, and so the laboratories have to take precautions on those sorts of things. And one of the things that you have to assume is that in the past, the rate of carbon-14 production was the same basically as what we see in the world today. That's an assumption that we can't directly verify. So that's an assumption about past conditions. Now, when we think about carbon-14 then from a young Earth perspective, we might have some questions. If God created the world originally and all the fossils that we find in the rock record were a result of the ecosystem that was buried, that might mean that carbon-14 values in the atmosphere were different, because it seems that there was a lot more carbon in terms of the biology in the world before the flood than we have today. So it could be that there wasn't as much carbon-14 because it was more spread out amongst all the different plants and animals.
Okay.
So that's a possibility. It also means, from what we've studied, that the Earth's magnetic field, which we know is decreasing, would have been stronger in the past, and that blocks carbon-14 from being produced. So we might have lower carbon-14 values just because not as much was being made. There also might be some things going on in the flood to pull nitrogen and carbon out of the system and then thus change our initial conditions. So that question of what was the bathtub level at the beginning is an open question for creationists here. So what's most interesting to me as a creationist, Don, is that starting from a creation perspective, you can ask questions that my evolutionary colleagues wouldn't think to ask, such as, is there going to be carbon-14 in deep rock layers that should be millions of years old on the conventional timescale? So what we've discovered is that there's carbon-14 really everywhere. Petrified wood, fossil shells, vertebrate fossils such as the mosasaurs that I study have been carbon-14 dated, and there's carbon-14 in them. Oil, petroleum, natural gas, coal are fossil fuels constantly being tested, and there's carbon-14 in all of these. And even diamonds, which are supposed to be billions of years old, have been shown to have carbon-14 in them. These are all expectations that young Earth creationists have had, but were not the sort of thing that a competing model from an old Earth perspective would have ever anticipated.
Sounds like kind of a conundrum for the old Earth people that we want to talk about. So this is really fascinating, but we have to take a break.
All right.
So you stay right there. We'll be right back. We're back with Dr. Marcus Ross, and Dr. Ross, right before our break, you were talking about carbon-14 being found in some places where, according to the popular theory, it shouldn't be found, even in diamonds that are billions of years old. How do you reconcile that?
You know, what I love about this is that these were questions that creationists came up with. Nobody prior to a group of creationists called the RATE team, working in the early 2000s, had ever thought to radiocarbon date a diamond, because it's already known, if you will, that they're 1.82 billion plus years old. And the trouble for explaining these from a conventional old Earth perspective is that a diamond is tremendously hard to contaminate. I mean, it's the hardest substance on the Earth.
What could penetrate?
And chemically, it's not very reactive.
Right.
And what you're trying to do is swap out a carbon atom, which is what the diamond's made of, with a radioactive carbon atom, but there's no physics and chemistry energetic reasons to make that switch. And so the expectation is there's nothing there. It's carbon dead. Graphite is another one of those minerals. It's carbon dead. It's assumed to be that way by all the labs, but they always kept picking up this little background. The creationists said, well, date it and see what you get. And they got a date of 60,000 years. Now, a young Earth creationist probably doesn't think that the diamond is 60,000 years either. But what this is telling us is that the original carbon is still there, and some of those things about how much carbon was at the pre-flood world, what was produced in the atmosphere, might give us a reason why it looks old, because we're making old Earth assumptions about the dating that's done. We're not challenging, say, how fast the decay rate has been or anything like that. We're just taking these numbers on face value. And it seems like no matter what you stick the probe into, no matter what sample you grab, if it was an organic material, at one point, if it was alive, it turns out it's got a carbon-14 signature. So I really like this because it's a question that only creationists thought to ask. But there's another challenge to the old Earth ages that is not directly related to the radioactive decay materials, and that is the preservation of original material from an animal's biology that didn't ever get fossilized. So in 2005, a paleontologist by the name of Mary Schweitzer published a paper in the journal Science. It's the top science journal in the country. in which she reported that bones from a Tyrannosaurus rex, the upper leg bone, the femur, had still inside of it the original blood vessels of the animal that never became fossilized. The outside of the bone was all fossilized, but the inside wasn't. It was an amazing discovery that was actually done by accident. They were taking some of the samples and they were putting them in a bit of an acid to demineralize them, and they were going to do that just for a little bit to clean them out, but the assistant left it overnight, and they came back and all the bone had dissolved, but there was still stuff inside. Now, I was trained as a paleontologist, and you put a bone in acid and there's nothing left the next day.
Right.
But there was still stuff in there, and it was biological material. This is a couple of the pictures from that paper. What we see on the left is a network of blood vessels. And those were...
blood vessels.
Blood vessels. T-Rex blood vessels. These were so intact that they were taking them with tweezers, and they were actually kind of pulling them, and they'd stretch and then snap back into place like a real blood vessel would do. You see these little red balls in there. Now, Schweitzer identified these as iron-rich spheres, and she didn't say anything more than that. Because there's two possibilities here. One is that it's a little sphere of pyrite. Pyrite is a fool's gold mineral, and it forms little balls. But the other possibility that she was hinting at more strongly is that these were original red blood cells for the T-Rex. And our red blood cells as mammals are flat and they have no nucleus. But all the other animals, all the fish, the amphibians, the birds, the reptiles, they have round red blood cells. So finding a little red round ball in the middle of a network of blood vessels told you, there's probably cells that are still in here as well, and a whole bunch of other gooey, gross-looking stuff. I mean, this looks like an anatomy dissection, and it really was. It got better. She kept coming back with more and more material because the scientists said, no, it can't be. I mean, it's 68 million years old. But instead, what she came back with was, hey, not only do we have this from a T-Rex, 4 years later, it comes back and says we also got it from a duck-billed dinosaur and another layer of rock lower below. It's supposed to be 80 million years. Same thing, they've got more of the blood vessels, and they've got the cells of the animal that made the bone in the first place. Taking a look at the little black arrow there, there's a small cell right in between where the blood vessels branch, and that's exactly where a cell called an osteoblast in our body is. And that's the cell that makes bone in the first place and gets kind of encapsulated in the bone. It needs to be next to the blood cells because it's being fed with nutrients to make the bone. And sure enough, it's there, and they compared it to other organisms. They looked at it under scanning electron microscopes. It's a cell. It's not made by bacteria. They were able to recover proteins and sequence those proteins and find out that there's collagen. That's one of the connective tissues that keeps your skin more or less where it is, flexible. So it's just amazing the stuff that they found in this. They started also discovering that there were additional proteins and possibly even small snippets of DNA. They recovered little DNA in a blender, bits and pieces in something like this. So, when I step back and we take a look at this, what we discover is that radioactive decay, once you get down into the details, is a challenge for creationists. I'm not going to hide that. There are some very, very difficult problems that creationists face with that. However, there are some areas where we have some big advantages, carbon-14 being one of them, I think, on that. And with the Bible guiding our science, we can actually create a hypothesis. We can pray and ask God to give us insight, and we can ask Him to lead us to a question that we need to ask. So we can do good work. Now, this talk has been a little bit of a summary of some of the material that's in my college textbook called The Heavens and the Earth. We wrote it with several other faculty at Cedarville University at Answers in Genesis with Dr. Danny Faulkner. And we also talk about this with a company that I put together with my wife and I. We actually make rock and mineral and fossil kits for homeschoolers, for Christian schools, so that they can learn about these sorts of things in geology and have a chance to get their hands on specimens and learn about God's creation from God's Word and from His world.
This is so fascinating. And I appreciate a couple things, Doc. I appreciate, first of all, how objective you are. When you say that there are things that don't quite line up with what we see as creationists, that there are difficult things, you're honest about that. Yeah. But then you're also saying, but what about this? We're not the only ones with some difficulties here. And that's tremendously helpful, because it's scientific. It's looking objectively at facts. And these kits that you're putting together, I mean, this has to be a homeschooler's dream, that you're helping them to have tools to learn and to grow.
Well, I need colleagues. I need little kids that get interested in rocks and fossils so that they can apply themselves to God's world.
And where you're sitting, where I'm sitting, you need a next generation that's going to keep on doing the discovery and doing the work, the good work of science from a biblical perspective. I'm fascinated with that dinosaur. Mary's not even a creationist, is she?
No, she's not.
But her evidence is overwhelming and irrefutable.
Yeah.
Yeah, very good. Thanks so much for being with us.
Thank you very much.
My friends, I hope today helped confirm in your mind and in your heart that it's God's view that He created you. He created not only you, but the whole world around us. And I think He did it not very long ago. And that needs to be your worldview too. Thanks for joining us today on Origins. Hope we'll see you back here again soon. God bless you, my friend.
Thank you for watching this edition of Origins. For a DVD of this series, you can order online or send a $12 donation to cover shipping and handling and write to Origins Program number 1706, Cornerstone Network, Wall, Pennsylvania 15148. If you like a copy of the PowerPoint information presented today, you can download an episode guide at originstv.org.
Origins is made possible by the faithful prayers and financial support of you, our Cornerstone family.